On July 1st, 2025, under the pristine skies of Rio Hurtado, Chile, the ATLAS, Asteroid Terrestrial Impact Last Alert System, telescope system captured a discovery that would fundamentally transform astronomical understanding during its routine sky survey, a faint yet rapidly moving point of light. This seemingly ordinary detection would, within the subsequent 48 hours, send ripples of excitement through the global astronomical community. The team led by astronomer John Torrey at the University of Hawaii identified anomalies during data analysis. The celestial body, temporarily designated a 2501, displayed an astonishingly steep trajectory with a breathtaking velocity of 58 kilometers per second. Within hours, observatory networks worldwide were alerted to this extraordinary finding. Orbital calculations yielded staggering results. The object's orbital eccentricity measured 6.15, significantly exceeding the critical threshold of 1.0. This unequivocally confirmed its status as an unbound interstellar wanderer, marking humanity's third encounter with an interstellar object following the discoveries of Oumuamua in 2017 and Borisov in 2019. Volume 2, Designation and Early Tracking. The International Astronomical Union promptly confirmed the discovery, officially designating it 3I Atlas. With this formal recognition, telescopes worldwide turned their attention to the new interstellar visitor. Astronomers worked through the night examining archival data, discovering faint images from June 14th in historical records from both Atlas and the Zwicky Transit Facility, ZTF. These early detection points enabled more precise orbital calculations and further verified its interstellar origins. By mid-July, key orbital parameters for 3I Atlas had been established. Perihelion date, October 29, 2025. Perihelion distance, 1.36 astronomical units, approximately 202 million kilometers. Expected perigee date, December 19, 2025. Perigee distance, 1.8 astronomical units, approximately 270 million kilometers. Volume 3, Political Turmoil. When Science Confronts Government Shutdown. As the scientific community celebrated this monumental discovery, a political crisis was brewing in Washington. On October 1st, 2025, the U.S. federal government officially shut down due to budgetary impasse. This political turmoil quickly impacted the scientific community, forcing the suspension of most NASA public programs. However, 3I Atlas continued its inexorable journey into the inner solar system, unaffected by political disputes. At this critical juncture, Congresswoman Ana Paulina Luna issued a public letter on October 4th demanding NASA immediately release all images and raw data concerning 3I Atlas. This discovery belongs to all humanity, not to a privileged few institutions, Luna emphasized in her correspondence. Scientific transparency becomes particularly crucial during government shutdowns. Volume 4, NASA's Dilemma and Response Strategy. Caught between political pressure and scientific responsibility, NASA faced a complex dilemma. The government shutdown had forced 85% of its workforce into furlough, severely hampering data processing capabilities, while the scientific value of 3I Atlas demanded immediate internal memoranda from NASA's Science Mission Directorate revealed a compromise approach. Essential scientific observations and orbital computations would continue with skeleton staff, but data release protocols would be significantly streamlined. The Jet Propulsion Laboratory's Deep Space Network maintained tracking operations, while core teams at the Goddard Space Flight Center continued their critical work. We must maintain scientific continuity within legal constraints, stated a NASA official who requested anonymity. 3I Atlas won't pause its motion because of a government shutdown. Volume 5, Perihelion Marvel and Anomalous Phenomena. On October 29, 2025, as 3I-ATLAS reached its closest approach to the Sun, space witnessed a spectacular cosmic performance. NASA's Solar and Heliospheric Observatory, SOHO, recorded a dramatic outburst. The comet's brightness quadrupled within minutes. Spectroscopic analysis revealed this was no ordinary cometary activity. Beyond typical water vapor signatures, scientists detected unusually high carbon dioxide concentrations, double the typical values found in solar system comets. More surprisingly, traces of cyanide and simple organic compounds were identified. JPL orbital specialists soon discovered even more extraordinary phenomena. 3I Atlas exhibited significant non-gravitational acceleration. Tracking data over subsequent days showed this acceleration peaking, clearly deviating from purely gravitational trajectories. It's as if an invisible engine is propelling it, observed Dr. Zhang Ming, an orbital dynamics specialist at JPL. We estimate it may have lost up to 13% of its total mass during this outburst. Volume 6, Scientific Community Response and Debate. On November 2nd, Professor Avi Loeb, chair of Harvard University's Astronomy Department, issued a public statement urging immediate and complete data disclosure. When dealing with potentially paradigm-shifting celestial objects, the scientific process must be completely transparent, Loeb stressed. Any delays could compromise the scientific community's credibility. Loeb's appeal garnered support from hundreds of scientists worldwide through joint signatures. However, the U.S. Army Research Office unexpectedly released a statement on November 4th, declaring that 3I Atlas had been thoroughly examined and classified as a natural interstellar comet, showing no signs of artificial origin or security threats. This debate highlighted profound divisions within the scientific community when confronting extraordinary discoveries between traditional scientific methods advocating cautious verification and enthusiastic anticipation of groundbreaking revelations. Volume 7, Emergency Response from Global Observation Networks. As the U.S. government shutdown persisted, the International Asteroid Warning Network, EON, assumed coordination responsibilities in early November. By this time, 3I-ATLAS was approximately 480 million kilometers from Earth and rapidly receding. The European Space Agency, ESA, played a pivotal hub role, coordinating observational data from Europe, Asia, and South America. This decentralized observation network demonstrated remarkable resilience. When weather conditions prevented observations at one station, partners from other regions could fill the gap within minutes. Amateur astronomers also contributed significantly to these observations. Enthusiasts from Poland and Australia using homemade spectrometers and modified CCD equipment captured dust particle alignment variations that even professional arrays struggled to resolve. Volume 8. China's groundbreaking contribution. While the international scientific community grappled with data accessibility issues, the China National Space Administration, CNSA, announced breakthrough news. The Tianwen-1 Mars orbiter had successfully captured clear images of 3I Atlas from its position approximately 220 million kilometers from Earth. This represented humanity's first close-range observation of an interstellar object by a spacecraft. At a distance of 30 million kilometers, Tianwen-1's high-resolution camera overcame tremendous technical challenges. The target was 10,000 to 100,000 times dimmer than the Martian surface, with a relative velocity reaching 86 kilometers per second. This was akin to photographing a candle several kilometers away on a dark night using a conventional camera, analogized Dr. Li Jun, project scientist for Tianwen-1. Our team developed an innovative imaging strategy combining precise pre-aiming with continuous, rapid exposure to achieve this breakthrough. Volume 9. In-depth exploration of scientific value. As data continued to accumulate, the scientific significance of 3I Atlas gradually emerged. Astronomers estimate this interstellar visitor to be between 3 to 11 billion years old, potentially predating our solar system. Its chemical composition displays unusually active characteristics, particularly the detection of glowing nickel vapor, a first among observed interstellar objects. Data from the James Webb Space Telescope further revealed that carbon dioxide content in its coma significantly exceeded water ice concentrations, providing valuable samples for studying exoplanet formation. This is like obtaining a cosmic archive preserved for billions of years, remarked Dr. Gunther Hassinger, ESA Director of Science. Every data point could reshape our understanding of galactic evolution. Volume 10. Ethical Considerations and Data Disclosure. Following the resolution of the government shutdown, NASA began gradually releasing backlogged data in early 2026. However, discussions regarding scientific data disclosure initiated by this incident continue. The scientific community has begun reflecting. In the digital age, how should we balance data quality control with public right to know? Should special data sharing mechanisms be established for scientific discoveries likely to generate widespread public interest? The 3I Atlas experience teaches us that scientific advancement requires both professional rigor and open sharing attitudes, stated Deborah Elmegreen, president of the International Astronomical Union, summarizing the incident. Each dataset released brings humanity closer to the cosmos. Volume 11, Future Prospects. Although 3I ATLAS is gradually disappearing beyond detection range, its scientific legacy will have far-reaching impacts. This experience has not only advanced observational technologies, but also fostered innovation in international scientific collaboration models. With more powerful telescopes coming online, such as the Vera C. Rubin Observatory, astronomers anticipate discovering more interstellar visitors. The most crucial lesson from 3I ATLAS is that humanity must maintain open-mindedness in cosmic exploration, preparing for more surprises. cosmic mysteries don't pause for human bureaucracy, Professor Loeb concluded in a recent address. 3IATLAS is just the beginning. True exploration has only just commenced. As we gaze at the stars, contemplating the revelations brought by this interstellar visitor, we recall the words of a Tianwen-1 project scientist. This observation serves both as validation of past technological accumulation and as a vision for future deep space exploration. In this universe filled with unknowns, every exploration propels civilization further toward the cosmic ocean. The initial detection of 3IATLAS on July 1, 2025, by the Atlas telescope in Chile was merely the first sentence in a long, complex cosmic telegram. In the hours that followed, astronomers worldwide engaged in a frantic and meticulous process of decoding its message. The object's hyperbolic trajectory, with an eccentricity firmly established above 1.0, was the definitive signature of its interstellar origin. But this was only the beginning. The process of refining its orbit became a global collaborative effort. Astronomers combed through archival data, uncovering pre-discovery observations from as early as June 14th from Atlas and the Zwicky Transient Facility, ZTF. Each data point acted as a cipher, tightening the constraints on its path and confirming its identity as only the third confirmed interstellar object, following Alma and Borisov. By mid-July, a clear timeline had emerged. A perihelion passage on October 29th at 1.36 astronomical unit, and a safe but intriguingly close approach to Earth on December 19th at a distance of approximately 2.7 billion kilometers. This period was characterized by intense scientific focus. The global network of telescopes, from the Hubble Space Telescope to the Very Large Telescope, VLT, in Chile, began their vigil. Hubble's early images confirmed a cometary nature, showing a teardrop-shaped coma of dust shedding from a rigid, icy nucleus, estimated to be between 440 meters and 5.6 kilometers in diameter. The stage was set for an unprecedented observation campaign of a visitor from another star. 2. The political gravity well. Just as 3I Atlas was succumbing to the sun's gravitational pull, it was nearly eclipsed by a terrestrial crisis, a U.S. federal government shutdown. This political event threatened to plunge NASA's public-facing operations into darkness, creating a unique and tense backdrop for the scientific discovery. The shutdown posed a direct challenge. With 85% of NASA staff furloughed, the standard protocols for data processing and public communication were disrupted. This created a vacuum of official information just as public interest was surging. Into this void stepped Congresswoman Ana Paulina Luna, who, on October 4th, formally demanded NASA release all 3IATLAS images and raw data. Her argument that a discovery of this magnitude belongs to all humanity resonated deeply with the public captivated by the cosmic visitor and frustrated by the information. NASA found itself in a difficult position, balancing scientific responsibility with political and operational realities. Internally, essential work continued. As confirmed by internal memoranda, the Jet Propulsion Laboratory, JPL, and the Goddard Space Flight Center maintained critical tracking and orbital computation with skeleton crews. The science, as one anonymous official noted, could not stop because the comet would not. However, the streamlined data release process led to a trickle of information, fueling speculation and debate. This situation highlighted a critical vulnerability in the modern scientific enterprise. The incident demonstrated how political dysfunction on Earth could potentially impede the global understanding of a celestial event, underscoring the delicate balance between necessary scientific validation and the public's right to timely information. 3. Perihelion Revelations and the Nickel Mystery. On October 29, 2025, 3IATLAS reached its perihelion, and the scientific payoff was immediate and stunning. Space-based observatories, including the Solar and Heliospheric Observatory, SOHO, recorded a dramatic outburst, with the comet's brightness quadrupling in a matter of minutes. Spectroscopic analysis revealed a chemical composition that set it apart from typical solar system comets. A key finding, reported by teams using the James Webb Space Telescope and Chile's Very Large Telescope, was an unusually high concentration of carbon dioxide, nearly double that of typical comets. Even more intriguing was the detection of cyanide gas and simple organic compounds, painting a picture of complex chemistry. The most captivating discovery, however, was the presence of glowing nickel vapor in its coma. This was not the result of simple high-temperature metal vaporization, as one might expect. Scientists proposed a more complex origin. The nickel might be bound in complex molecules, such as nickel carbonyl or other organic compounds, which were breaking apart under sunlight to release nickel atoms. The concurrent non-detection of iron further puzzled researchers, suggesting a unique and fractionated metallurgy within the object. This peculiar chemical signature offered a vital clue to the comet's history. As Michigan State University astronomer Darrell Seligman noted, the coma's richness in CO implied it must have formed in a very cold place, far from its parent star. This environment might have allowed for the preservation of these exotic metal organic compounds, providing a frozen record of its birthplace's conditions. The following timeline outlines the key milestones in the observation of 3I Atlas and the emergence of its anomalous features. 4. The technosignature debate rekindled. The combination of anomalous data and a constrained information flow created a perfect storm for speculation. Harvard astronomer Avi Loeb, who had previously argued that Al-Mamua could be an artificial object, found new fuel for his hypotheses in 3IATLAS. Loeb pointed to the object's immense size, estimated at 10 to 20 kilometers in diameter, making it 1,000 to 1,000,000 times more massive than its predecessors, and its unprecedented activity as potential indicators of something more than a simple cosmic snowball. He speculated that an alien mothership could use the sun's gravity for a slingshot maneuver, hiding behind the star just as 3I Atlas did during its brightest phase. The scientific mainstream responded with unified skepticism. NASA's lead scientist for small bodies, Tom Stadler, emphasized that all available evidence indicates that 3I Atlas is a natural body, aligning with known cometary features, albeit with unusual quirks. He aptly noted that the heaving of a comet's dust and ice mixture can lead to unpredictable reactions. Professor Chris Lintott of Oxford University was more blunt, dismissing Loeb's theory as nonsense and expressing his full confidence that it is a comet. This debate, playing out in scientific journals and across social media, highlighted a fundamental tension in modern science: the balance between open-minded consideration of extraordinary possibilities and the rigorous, evidence-based conservatism that forms the foundation of the scientific method. Loeb himself acknowledged in a blog post that the simplest hypothesis is that 3I Atlas is a comet, but he continued to press his case as a challenge to conventional thinking. V. A global effort and a Chinese milestone. While the political drama unfolded in the U.S., the scientific effort to study 3I Atlas became a truly global endeavor, demonstrating the international nature of space science. The European Space Agency, ESA, coordinated observations from its member states and operated missions like the Jupiter Icy Moons Explorer, JUICE, which tracked the fast-moving object. A pivotal moment came when China's National Space Administration announced that its Tianwen-1 Mars orbiter had successfully captured clear images of 3I Atlas from its position around Mars. This marked the first close-range observation of an interstellar object by a spacecraft, a significant technological achievement. The Tianwen-1 team had to overcome immense challenges, as the comet was vastly dimmer and moving at a much higher relative speed than the orbiter's cameras were designed to track. This success underscored China's growing prowess in deep space exploration and its increasing role in major astronomical discoveries. The international collaboration extended to a coordinated observation campaign managed by the International Asteroid Warning Network, IAWN. This decentralized network, involving professional observatories and amateur astronomers alike, proved highly resilient. When one station was down due to weather or technical issues, others around the globe could fill the gap within minutes, ensuring a continuous stream of data as 3I Atlas began its retreat from the inner solar system. Vi. Scientific legacy and the path ahead. As of November 2025, the story of 3I Atlas is far from over. NASA has scheduled a press conference for November 19th to release new images from its space-based assets, which are expected to reveal how the comet's activity changed after its close solar passage. The global astronomical community continues to monitor its departure, with all eyes on its closest approach to Earth on December 19th. Regardless of the unresolved questions, 3I Atlas has already provided a treasure trove of scientific data. Its estimated age of 30 to 110 billion years suggests it is older than our solar system, making it a pristine relic from an alien planetary system. Its unique chemical makeup, particularly the nickel and high CO content, provides a direct sample of the building blocks of planets around other stars, offering insights into the diversity of planetary formation in our galaxy. The episode has also served as a real-world test of global scientific protocols and public communication under duress. It has highlighted the need for robust apolitical frameworks for sharing data on transient celestial phenomena. Furthermore, it has ignited public interest in space science like few events before, inspiring a new generation to look up at the stars in wonder. In the words of a project scientist from the Tianwen-1 mission, this observation was both a validation of past technological accumulation and a vision for future deep space exploration. As 3I Atlas continues its journey back into the interstellar dark, It leaves behind a transformed understanding of our cosmic neighborhood, one that is more connected, more dynamic, and more mysterious than we ever imagined. The silent, inscrutable visitor has delivered its message, and humanity is now tasked with deciphering its full meaning. As 3I at TLAS journeyed away from the sun, the data from the world's premier observatories began to paint a detailed and startling picture of its chemical makeup. The initial findings of abundant carbon dioxide and nickel were merely the preface to a more complex story written in the object's spectrum. The James Webb Space Telescope, JWST, and the SPHERX Observatory played pivotal roles in this chemical dissection. Their combined data confirmed that the comet's coma was dominated by carbon dioxide, CO, with a CO to water ratio dramatically higher than that of typical solar system comets. This suggests it formed in an extremely cold region of its home star system, far from the stellar heat that would have boiled away such volatile ices. Intriguingly, the comet's water ice was detected in solid form, with a notable lack of significant water vapor in its early stages of approach, further indicating a different thermal history. Perhaps the most profound chemical discovery was the detection of methylamine in the comet's spectra. Methylamine is a prebiotic molecule, a building block for more complex organic compounds like amino acids, the fundamental components of life on Earth. This finding does not imply the presence of life on 3I Atlas, but it powerfully demonstrates that the essential ingredients for life can form and survive in the harsh environment of interstellar. The discovery of such life's ingredients on an object potentially over 7 billion years old strongly implies that the universe has been manufacturing the raw materials for life for eons, making their presence a common feature across the galaxy. The peculiar nickel signature also came into sharper focus. While its concentration was anomalous, scientists proposed that the nickel might not be in pure metallic form. Instead, it could be bound in complex molecules, such as nickel carbonyl, or its surface could have been altered by billions of years of exposure to cosmic radiation, changing its reflective properties. This offers a natural, albeit unusual, explanation for the spectral data that initially fueled speculation about an artificial hull. 2. Refining the physical portrait from giant to ordinary comet. Early estimates based on the object's brightness suggested a colossal nucleus potentially 10 to 20 kilometers in diameter, fueling imaginations about an unprecedented interstellar giant. However, as often happens in astronomy, more precise data from the Hubble Space Telescope corrected this initial impression. Once the obscuring effect of its extensive dust coma was accounted for, Hubble's high-resolution images revealed a much more modest nucleus. The diameter of 3IA2LAS was refined to a range of 0.44 to 5.6 kilometers, with a figure of 5.6 kilometers being a commonly sized. This placed it firmly within the normal size range for comets, demoting it from a hypothesized behemoth to a fairly standard, if active, icy body. This revision was a critical step in demystifying the object and aligning its properties with known cometary science. The comet's non-gravitational acceleration, a key anomaly highlighted by Professor Loeb, was also addressed by mainstream science. The acceleration profile was found to be consistent with a natural process called outgassing. As the comet's ices were heated by the sun, they sublimated directly into gas, jetting off the surface. The reaction force from these jets acted like a natural, if slightly erratic, thruster gently pushing the comet off a purely gravitational path. Professor Chris Lintott of Oxford University offered a simple analogy. It's like letting go of a balloon. The escaping air pushes it around. The pronounced effect on 3IATLAS was simply due to its high level of activity, not a hidden engine. The timeline below summarizes the key milestones in the observation of 3I Atlas and how our understanding evolved. 3. A global campaign, Eyes on the Sky. The study of 3IATLAS swiftly evolved into a remarkable example of international scientific cooperation. While the U.S. government shutdown created temporary obstacles for NASA's public outreach, the core scientific work never stopped. The Jet Propulsion Laboratory, JPL, and the International Asteroid Warning Network, IAWN, continued to coordinate tracking and observation efforts, ensuring a continuous flow of vital data. This global network proved incredibly resilient. When one observatory was hindered by weather or darkness, others across the globe would pick up the vigil. A significant contribution came from China's Tianwen-1 Mars orbiter, which successfully captured high-resolution images of the comet from its post at Mars. This demonstrated China's advanced capabilities in deep space exploration and provided a unique, close-range perspective on the interstellar visitor. The European Space Agency also played a crucial role, with its Jupiter Icy Moons Explorer, JUICE, and ExoMars Trace Gas Orbiter, both turning their instruments towards the comet, adding valuable data sets from different locations and instruments. Furthermore, the community of amateur astronomers worldwide contributed significantly, tracking the comet's brightness and position and providing a widespread, passionate watch party for this historic event. 4. The consensus and the enduring mystery. Despite the captivating alien spacecraft hypothesis put forward by Harvard's Avi Loeb, the overwhelming consensus within the scientific community is that 3I Atlas is a natural interstellar comet. As Daryl Seligman, a leading researcher on the object, stated, a vast amount of telescope observations of 3I Atlas show it displays characteristics of cometary activity. The object's true significance, therefore, lies not in what it might artificially be, but in what it naturally is, a pristine messenger from a foreign star system. Its unique chemical signature rich in CO, laced with prebiotic molecules, and possessing an unusual metal ratio, provides a direct sample of the building blocks of planets from another star. This allows scientists to test theories about planetary formation and the prevalence of life's ingredients throughout the galaxy. As Professor Lintott summarized, it represents a chance to understand what happened in the early history of our galaxy. The journey of 3I Atlas through our solar system is a fleeting one. It will make its closest approach to Earth on December 19, 2025, at a perfectly safe distance of about 2.7 billion kilometers. After a final gravitational kick from Jupiter in March 2026, it will depart our solar system forever, continuing its silent voyage through the galactic void. Its brief visit, however, has left an indelible mark, sharpening our observational tools, strengthening our collaborative spirit, and offering a humbling, exhilarating glimpse into the vast and diverse cosmos beyond our sun's influence.